Picture this, it's Friday afternoon, and you're stuck manually copying data from 5 different spreadsheets, formatting cells, creating charts, and preparing your weekly report. Sound familiar? What if I told you that Python can do all of this in under 30 seconds while you grab a coffee? Today, we're building an Excel automation system that will change your life forever. Let's be real about what manual Excel work actually costs you. On one side, we have the old painful way: hours of repetitive clicking, copy-pasting, and praying you didn't miss a cell. On the other side? Pure automation magic where Python does everything perfectly, every single time. The numbers don't lie. Data professionals waste an average of 12 hours per week on manual Excel tasks. That's 624 hours per year, over 15 full work weeks. But companies using Python automation see a 90% reduction in report creation time and save an average of $50,000 per employee annually. Plus, error rates drop by 95% because humans aren't manually copying data anymore. First things first, we need to install the right Python libraries. OpenPyXL is our main weapon for Excel manipulation. Pandas handles data like a boss, and we'll use Matplotlib for creating charts. Just copy this command into your terminal and hit enter. This will download and install everything we need. Installation commands for setting up the Python environment. We're installing OpenPixel, which provides Excel file manipulation capabilities, Pandas for data processing and analysis, Matplotlib for creating charts and visualizations, and Pillow for image handling. The verification commands check that each library installed correctly by attempting to import them. Now let's create our main automation script. We start by importing all the libraries we just installed. Each import gives us superpowers: OpenPixel for Excel files, Pandas for data manipulation, Datetime for timestamps, and OS for file operations. Think of these as your automation toolkit. Import statements for our Excel automation script. The OpenPixel library is imported with its workbook class for creating new Excel files, styles module for formatting, font for text styling, pattern fill for cell colors, alignment for text positioning, and chart module for creating bar charts with data references. Pandas is imported as PD for data manipulation, Datetime for adding timestamps to our reports, and OS for file path operations. Here's where the magic starts. This function reads Excel files from a folder and combines them all into one dataset. The function takes a folder path as input, loops through all Excel files using os.lister, reads each file with pandas, and appends them to a list. Finally, we use pd.concat to merge everything into one clean data frame. This means you can drop any number of Excel files into a folder, and Python will automatically process them all. The read_Excel_files function handles data loading from multiple Excel files. It accepts folder_path as a parameter specifying where Excel files are stored. The all_data list accumulates data frames from each file. The for loop iterates through all files in the folder, checking if each file name ends with .xlsx or .xls extensions. For each valid Excel file, os.path.join creates the full file path, pd_read_Excel reads the file into a pandas data frame, and the data frame is appended to all_data. A success message prints for each loaded file. Finally, pd.concat merges all data frames vertically, ignore_index equals true resets the index, and the function returns the combined data frame with a summary of total rows loaded. Let me show you what this looks like in action. You simply point Python to your data folder, and it automatically detects every Excel file, reads them, and combines them into one clean dataset. No more opening files one by one. Raw data is usually messy, so we need to clean it up. This function handles common data cleaning tasks. We start by removing any duplicate rows because duplicates can skew our analysis. Then we fill in missing values with 0. You could also use forward fill or other strategies depending on your data. Next, we filter the data to only include rows from this year using datetime. Finally, we calculate some summary statistics like total sales, average order value, and monthly trends. This gives us clean, analyzed data ready for our report. The process_data function cleans and analyzes the data frame. It takes df, data frame, as input. The drop_duplicates method removes any duplicate rows from the dataset. The filna, 0, method replaces all missing values with 0 to prevent calculation errors. The date column is converted to datetime format using PD2_datetime for proper date operations. We get the current year from datetime.now.year and filter the data frame to only include rows where the date year matches the current year. The summary dictionary stores calculated metrics. Total_sales sums all values in the sales column, average_order_value calculates the mean of sales, total_orders counts the number of rows using len, and monthly_sales groups data by month and sums sales for each month. A formatted print statement shows the processing results with comma-separated numbers and 2 decimal places. The function returns both the clean data frame and the summary dictionary. Now for the fun part, creating a beautiful Excel report automatically. We create a new workbook and rename the first sheet to Dashboard. Then we add a styled header with a bold white font on a blue background. This makes it look professional. We populate the summary statistics in clean, formatted cells. Each metric gets its own row with labels and values. The alignment makes everything centered and easy to read. This is just the beginning. You can customize colors, fonts, and layout however you want. The create_Excel_report function generates a formatted Excel file. It takes 3 parameters, df, the data frame, summary, the statistics dictionary, and output_file, with default name sales_report.xlsx. A new workbook object is created and assigned to WB. The active worksheet is accessed via WS and renamed to Dashboard. Cell A1 becomes the report header with the text sales report, styled with font size 16, bold, and white color, FFFFFF. Pattern fill applies a solid blue background color, 4472C4. Alignment centers the text horizontally. The merge_cells method spans the header across columns A through D. The row variable tracks the current row number, starting at 3 to leave space after the header. Summary statistics are added as label value pairs, total sales in column A with the formatted dollar amount in column B, with thousand separator in 2 decimals, styled in bold green font, 008000. The row counter increments for each new statistic. Average order value is added similarly with dollar formatting. Total orders displays the count in bold font. Next, we add the actual data table. We start by creating column headers in row 8, each with bold formatting. Then we iterate through our data frame, adding each row of data to the Excel sheet. The enumerate function gives us both the row index and the data, making it easy to populate the cells. We use cell.value to assign data and add number formatting for currency values. Finally, we adjust column widths so everything fits perfectly. Continuing the create_Excel_report function, we now add a data table. Row 8 becomes the header row for our data table. The headers list defines column names. The enumerate function loops through headers with call tracking the column number, starting at 1 for Excel's 1-based indexing, and header containing the text. For each header, ws.cell creates or accesses the cell at the specified row and column, assigns the header value, applies bold font, and adds a light blue background fill, D9E1F2. The nested for loop iterates through the first 20 rows of the data frame using df.head, 20.iteros, which returns both the index, IDX, and the data row. Row increments for each data row. The date is formatted as YYYIMMDD using strtime. Product name goes in column 2, sales amount in column 3 with currency formatting applied via number_format property, $###0.00 displays $sign with thousand separator in 2 decimals, and quantity in column 4. Finally, column_dimensions sets optimal widths for each column so content displays properly without truncation. Time to add some visual flair with charts. We create a new sheet called Charts and add a bar chart showing monthly sales trends. The reference object tells Excel which data to use for the chart. We're pulling from the monthly sales we calculated earlier. We set the chart title, axis labels, and position it nicely on the sheet. Charts make your reports instantly more readable and impressive. Finally, we save the entire workbook to a file. The final section of create_Excel_report adds charts. We create a new worksheet named charts using wb.create_sheet and store it in chart_sheet. A bar chart object is instantiated and customized with a titled monthly sales trend and axis labels for month and sales. The months list extracts month numbers from the monthly_sales index, and sales list gets the corresponding sales values. The zip function pairs each month with its sales value, and enumerate provides the row index starting at 2, row 1 is for headers. Headers month and sales are written to row 1. For each month sale pair, we write the formatted month label and sales value to the chart data area. The reference object for data points to column 2, sales values, from row 1 to the last data row. The cat's reference points to column 1, month labels, starting from row 2. The add_data method attaches the sales data to the chart with titles_from_data equals true to use the first row as the legend. Set_categories assigns the month labels as x-axis categories. Add_chart places the chart object at cell D2 on the chart sheet. Finally, wb.save writes the entire workbook to the specified output_file, and a success message prints. The function returns the output file name. Here's the main function that ties everything together. This is what actually runs when you execute the script. We define the folder where your Excel files live, then call each function in sequence, read the files, process the data, and create the report. The if name equals main block ensures this only runs when you execute the script directly. Just update the data folder path to point to your files, run the script, and boom, instant automated report. The main function orchestrates the entire automation workflow. It prints a startup message with a rocket emoji. The data_folder variable stores the path to where Excel files are located, set to ./data but should be updated for your actual folder. The output_file variable dynamically generates a file name with today's date using datetime.now, .time, %y%m%d, resulting in names like sales_report_20241118.xlsx. The automation executes in sequence. Read_Excel_files loads and combines all Excel files from the folder into DF, process_data cleans the data and calculates summary statistics returning both the clean DF and summary dictionary, and create_Excel_report generates the formatted Excel file with charts and returns the file name. Success messages print when complete. The if _name _equals _main_guard ensures the main function only executes when the script is run directly, not when imported as a module. This is the entry point, just run python excel_automation.py in your terminal.